With scatter plots, all you're doing is graphing ordered pairs. You're just going to graph ordered pairs, and you're going to see what they do. Okay? So you can see with the trend on this scatter plot, it kind of increases, gets to a maximum point, and then it starts to do what? Decrease. Okay, what happens with this scatter plot? It's very condensed to what? The front half of the graph, right? And is there much of a pattern in this front half? No. But we can learn one thing, it's pretty condensed towards the front half. Okay? But otherwise we're not going to learn much there. Okay? Different trends. And we're going to talk about trend lines tomorrow or on Monday, okay, with the scatter plots. But if it looks like it's increasing as you move to the right, so the way we read a book is from left to right. We read a graph the same way, from left to right. And from left to right, if it looks like it's increasing, it's called a positive correlation. Good. And then if we can't really tell what's happening, kind of like that first one that we had on that second graph we had on the first page, we can't really tell what's happening. We just say there's no correlation. So you have positive correlation, negative correlation, and no correlation. Okay. How about this first one on this page? What kind of correlation does that have? Good. You're going to say for the first half of the graph, it's got a positive correlation. And then for the second half of the graph, it's got a negative correlation. Very good. And then this one we said would be what kind of correlation? No correlation. We can't really tell. Okay. And then if the points are really close to each other, it's a strong correlation. Where if they're not very close to each other, a weak correlation. Okay, so let's go back to these. What kind of strong or weak correlation here? Strong. A lot of the points in some areas are so close to each other that you can't even tell the difference between the points. Okay, and then this one, it's weaker than this, but I would still say it's pretty strong because all those dots are really pretty close to each other there. Okay? But yes, weaker than the second one. Okay, so the first one, we're going to label it as positive, negative, or no correlation. And then we're going to also label it as strong or weak correlation, all four of these. Okay, so the first one, top left here, positive, negative, or no correlation. Negative, because it's decreasing. And then is it strong or weak? Okay, the beginning is pretty weak, but then look at it, in here we get some points that are touching each other, so that means they're really, really close to each other. So I'm going to say, for the most part, it's pretty strong. Okay. How about the top right? Positive, negative, or no? It's a slightly positive increase. As we go to the right, it's starting to increase. Okay? Come on. There it is. Okay, and then strong or weak? That one is more weak where they're spread out. Okay, how about, does anybody know what an outlier is? An outlier. An outlier. Go back to the Western days. Back in the Western days, what would they call an outlaw? An outlaw was what? Somebody that was a bad person outside of the law. They're looking for them, right, because they're doing something bad. An outlier then is outside of the rest of the data. Okay, it's not close to the rest of the data at all. So, is there a point in this first graph that's not really close to the rest of the data? You can maybe say the first one, but I would say just because of the trend, it's pretty close to everything else. Now, is there a definite outlier in this one? Yeah, which point? Very top right is an outlier. Okay, because it's not even close to the rest of the data. Okay, so if you don't know what an outlier is, you might want to write that down, and we can write that down over here to say an outlier, a data point, far from the rest of the data. And sometimes there might be more than one data point, but a lot of times you're only going to see one outlier or maybe two outliers at the most in one set of data. Okay? Questions about an outlier? Okay, then let's look at these bottom two graphs. Positive, negative, or no correlation? No correlation. And strong or weak? Weak. Last one. Positive, negative, or no correlation? Negative. And then strong or weak? That's a little bit stronger. Okay. Here's my other thing. Let's go. We're going to go back and talk about this. What are my two variables in that first graph? Okay. What do they represent? Annual temperature, average temperature. So you have elevation and average temperature. So you could say what, if you were to summarize the data in here, you could say what? As something what, the other what? Okay? As the elevation increases, what's happening to the temperature? The temperature is decreasing, right? Okay, so that's what you would say about this one. As the elevation increases, temperature decreases. How about over here? Okay, so what would you say for the relationship between them? Okay, the more education you have, the higher your income is going to be. According to this. According to this. That's like 12 years of high school and 4 years of college. That's 16. Okay? How about here? What are your two variables? Shoe size and IQ. They have nothing to do with each other. Does it make sense to have no correlation then? Yeah, right? Just because you have size 4 feet doesn't mean you're going to have a low IQ. And because you have a size 22 shoe doesn't mean you're going to have a high IQ. Okay? Okay, so the last one, your variables. So what's it say? So as your time increases for study, your exam scores. What? Your exam scores what? Will increase too. You would think, but is that what this one shows? Okay. This one encourages the wrong thing, right? Because it says the time spent studying is increasing. What happened to the exam scores? I don't know if that's true, but. Okay. Oh, you guys are funny. Okay. So the next thing, you're going to make your own scatter plots now. Okay. So I give you the points. You have to graph them. Okay. I didn't label the axes or the axes. Okay. I didn't label the axes, and I did not give you intervals as to what to go by on each axis. So you have to figure those out. Okay, so we have dollars spent, gallons bought. You have to figure out which one is dependent on the other. The dollars spent is the gallon. The gallon bought is dependent on the dollars spent. It's the opposite. The dollars spent is dependent on the gallon the dollars that you spend is going to depend on how many gallons you put in your car of gas, right? If you only put 2 gallons in, you're going to spend less. If you put 8 gallons in, you're going to spend a lot more. So the dollars that you spend depends on how many gallons you buy. So really, dependent variable goes on which axis? Do we remember? Dependent goes on the y. So this is our y, this is our x. Okay, so we can now label our axis. This is our dollars, and then this is our gallons. Now, what do we want to go by on the x-axis for our gallons? So to figure out what you go by, look at your minimum point, look at your maximum point. What's our minimum number for gallons? Okay, so we go from 1.1 to what's our maximum? 2.8. So I'm going from 1.1 to 2.8. Am I going very far? Oh, 3.3. Okay. 1.1 to 3.3. Am I going very far? So our interval is going to be very large. Even if you go by 0.5, that's going to be a lot. Maybe by 0.2 or 0.3. Okay? I'm going to go by 0.3s just to make sure that we make it. Okay, and I'm going to do something that is called, that little squiggly there means skip a few.
I know that.
Okay? And I'm going to start at 1. And then I'm going to go 1.3, 1.6, 1.9, 2.2, 2.5, 2.8, 3.1, 3.4. And maybe we probably, because of the space that we have left, we probably could go by 0.2s. Okay, so let's try that. Yep, I have to erase. I have to erase too. You're right. And you're not going to, you might, because you might not know that in the beginning either. So you have to try things. So we learn together. That's good. So 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.8, 3, 3.2. Look at that. That looks a lot better. Okay? Very good. Okay? Oh, JJ said we got to erase. We got to go by 0.1s, I guess. No, we're not gonna. Okay? Dollars spent. What's our minimum? What's our minimum dollars spent? 4, and what's our maximum dollars spent? 13. Okay? So what do we want to go by? $2. Okay? So we start at 0, 2, 4, 6. Okay? I got to my max. 13 is my max. I don't need to go higher than 14. Okay, now we graph. Okay? So my first point, 2.5 on the x and 10 on the y. Go to where they meet, put that point there. 2.8 on the x, 11 on the y. 2.3 on the x and 9 on the y. 2.6 on x, 10 on y. 3.3 on x, 13 for y. 1.3 on x and 5 on y. 2.2 on x, 8 on the y, and 1.1 and 4. It doesn't look like the rest of our scatter plots. Brooklyn, why is that? That's exactly right. We don't have nearly as many data points as our last scatter plots that we've looked at had. right? I mean, there's a lot of data points in those first ones that we looked at. Probably hundreds of points, okay? Now here we only have maybe 8 or so points, okay? So, make a scatter plot of data. Identify independent, dependent variables. Which one was independent? X is independent, so it was gallons. What's dependent? Dollars. Choose a good scale. Okay, we chose a good scale. It took us a couple tries on the bottom. On top, we were fine. Okay, what type of relationship does the scatter plot show?
None.
Positive, negative, or no? Positive. It's increasing as we go to the right. Okay, and is it strong or is it weak? I would say that one's pretty weak because it's spread out pretty good.
Okay, so if they're not like in a bunch of clusters, they're strong.
Good vocab word, clusters. If they're clustered, they're strong. Good job, Brooklyn. Okay? Now, not everything deserves a reward in life. Okay? Describe the data. Describe the data as what does what, then the other variable does something.
As the balance increases, the obviously decreases.
That's what I want to hear. Okay, Alex? Good. Okay, so as the gallons increase, or as you buy more gallons, or as you get more gallons, the money increases. Okay, and that's how you would describe the data. As the gallons increase, the money increases. Questions on making a scatter plot? You will have to make scatter plots for homework over the weekend. Okay, here we go. This is when you kind of start thinking of correlations between variables, and do you expect one to be there or not? Okay, consider the population of a city. Okay, use Fargo as an example. And the length of the name of the city. Okay, so Fargo, for example. Would you expect a positive correlation, a negative correlation, or no correlation between the two sets of data? So you have population of a city and name of a city. Talk with someone next to you about what you think and why. Okay, 3, 2, 1. Positive, negative, no. Why?
Because the name and the population are two different things.
They have nothing to do with each other, right? The population is not going to determine the name.
I thought we were actually trying to figure out something.
The name.
No, sometimes it works. If you said Hollywood, I would have been there.
Yeah, but the name. What's population mean? It doesn't. Population doesn't mean popularity. Population means how many people live there.
Yeah, I know, but still.
So Fargo only has 5 letters, but it's the largest city in North Dakota. Largest population is Fargo. Yeah. Okay? By far. It's not even close. Fargo is by far the largest city in population. Okay? Bismarck doesn't have near the population Fargo has.
Why aren't we the capital?
Because Bismarck's centralized. It's in the center of the state. Right? A lot of times, if you look on a map, most of the capitals are going to be in the center of the state. Not all. But a lot of them, they try to centralize it in the center of the state, the capitals. Okay? So, no correlation. They don't affect each other. Now what I want you to do, think of 2 real-world variables that would have a positive correlation. So as one increases, the other increases. Think of another example of 2 variables where they have a negative correlation. So as one increases, the other decreases. And then think of one that has no correlation. Okay? So try and think, yeah, you can probably think of a lot of no correlations, but I want you to try and think on your own a positive, a negative, and a no correlation. So positive means they both increase and or both decrease. Negative means one increases, the other decreases. No correlation means they don't relate to each other at all. Okay? Try and think of one of each. I'll give you a couple minutes.
I don't understand. How are you supposed to do it?
Two variables that, as one increases, the other one is going to increase as well. We had some examples here. Back here. I don't want you to use these, but these are some examples. Okay? More use of education, higher your income. They both increase. That was positive. Here's a negative. Elevation increases, but the temperature decreases. Okay, so there's some examples. I want you to think of your own. Okay? One positive, one negative, and then one that has no correlation. Okay, now I want you to talk to somebody next to you and share what you thought of for a positive, for a negative, and for a no correlation. Okay, what were some of your things that you guys thought of for positive? Brooklyn? Okay, so the more you advertise a product, the more you sell a product. Okay, that would probably be true. Okay, anybody else have a positive they want to share? How about most of you are going to start doing this soon? The more hours you work, the what? The more money you're going to get paid. Okay? How about a negative correlation? What's a negative correlation you guys thought of? Usually for students, negative correlations are a little more difficult. Brody, what do you have? Awesome. Perfect. That's good. Okay? The more miles you drive, the less gas you're going to have. So as the miles increase, gas decreases. Okay? Any others? Charlie? Okay. Any others?
The more you talk,
The more you talk, the more Mr. Lee
the more you yell.
Yeah, no, the
Think
more we
about
talk,
using
the
your
less
voice.
time we have to work on our homework.
There you go. The more time you talk, the less time you have to work on your homework. Very good. How about no correlation?
Oh, how many people eat pizza and how many people eat hot dogs?
Okay? They probably have no correlation to each other. How many people like math and how many people like gym? Okay? All right, last thing. Last thing before you work on your homework. Okay? Strong, weak, or positive, negative, or no. And then weak or strong. And then we're going to add in this one. Linear or nonlinear. Okay? So, first one. We have variable 1 and variable 2. We don't know the variables. But is it going to be positive or negative? Positive. Strong or weak? Weak. And then is it linear or nonlinear? What does linear versus nonlinear mean? What does linear mean? Straight line, right? Same amount, okay? Nonlinear means obviously not the same amount. Linear or nonlinear? This one is linear. The reason is because it goes at a trend like that. Okay? It makes almost what would be like it looks like a straight line. Okay? And then outlier anywhere? Where? Okay? There's your outlier. Okay, next one. Positive or negative? Negative. Okay? Strong or weak? I'd say that one's pretty strong. Linear or nonlinear? There you go, because that one curves. And then, any outliers? No. Okay. Next one. Positive or negative? This one goes down to the right, so that's negative. Okay, strong or weak? Weak. And then linear or nonlinear? That's pretty linear. It goes down at a straight line. And then any outliers?
Yeah, that one at the top.
You could maybe say the one at the top, but it's not too far away. Okay? This one. Positive or negative? Strong or weak? And linear or nonlinear? I'd say this is linear. And then any outliers? Okay, very good. Questions today? Outliers? Yes. Always circle the outliers like we did here. Okay, so homework. I-5 worksheet, please, for homework this weekend. Yes, you can listen to music.